Okay, this is the uh, video tutorial for chapter 8 of my textbook, and the chapter 8 is a simple frame analysis. It's actually the same geometry that I have in chapter 7, except that 7 was a three-member truss, whereas here we are extending that to a three-member frame. Okay. So basically, we have a situation like this. We have a frame structure. These three pieces are welded together, therefore it makes a frame. And there are restraints that you can see here. Two of them are fairly straightforward. The third one is at a 45-degree angle, so we have to do a little bit of extra work here. And a load is applied, and the cross section of these three members, two of them are the same, and it's 24 by 24 millimeters squared, and the third one, the slanted one, is 34 by 34 millimeters squared. Okay, so what we're going to do is we're going to create 4 points and 3 lines. The 4 points, three of them are used to define the geometry of the frame, and the fourth one is, which is down here, is used for the orientation, specifying the orientation of a rectangle or the cross section. Because remember, if the cross section is circle, it doesn't matter how it's oriented. It's always circle. It's perpendicular to the length of the member. But if it's a rectangle, for example, or it's anything but a circle or a tube, basically, circular tube, then the orientation, it impacts the deformation of the structure. So yeah, the coordinates are given here, and the material properties are standard steel, and the load of is 1,000,000 Newton. Now, notice that when you do it as a frame structure, because the orientation, because the shape of the cross section and orientation is important, then uh, this is what you got. This particular one is the top one is the 24 by 24 square cross section, and this is the slanted one, which is 34 by 34 millimeter. Okay. So let's go ahead and do that. Let me start with the part file. I'm going to create 4 points. 4 points. Let's make it 0, 0, 0 is point number 1. Then we go up by 1,000 millimeters. Then we go to the right by 1,000 millimeters. That's point 3. I think that's what you got. Let's make sure that, let me see what you got here. Say okay, we may have to change some of these. How many do I have? How many points do I have? This last one, I didn't need it, so I'm going to delete it. Okay, so let's view, put everything on the screen. So we have point 1, point 2, point 3. Okay, yeah. So we add another one, which is bringing it down to 0. So this is point 4. This is the orientation point here. So let's see 1, see now, 1, 2, 3, and 4. Okay, good. Now we're going to create our lines. So here is line number 1 going from here to here. Line number 2 going from there to there. And line number 3 going from here to here. Okay. The other thing is that when I did chapter 7, I did not create a local coordinate system. So to specify the displacement correctly on a 45-degree angle, I ended up rotating the coordinate system that the menu gave me, dialog box gave me. So here, uh, as it's done in the book, I'm going to create an axis system. See that? The axis system. It says, where is the origin? The origin, I'm going to place it right there. And it says, okay, how are you going to line these up? So I'm going to line it up so that this is my x-axis. I think in the book, this is your x-axis. Let me double check on that. The x-axis is actually, let me just check. Sorry, the z-axis lies on this line. So z-axis, you select this, is on that line. Okay, so this is how it's done in the book, but as I said in number 7, chapter 7, I didn't do it in this way. Okay, so first thing we're going to do is we're going to save everything. Oops, save everything. Okay, so material. So let's apply our material. Add the material. Let me call this my chapter 7. Chapter 7. So it's going to create a shell for me with the name chapter 7 right there. And I'm going to specify, I can specify the material properties right here by saying right click, give me the numbers, simulation, structure, abacus multiphysics, mechanical, elasticity, elastic constants. This is 200, 200 e to the 9 Pascal, which is going to convert it to PSI, and this is 0.3. Now, if you wonder, well, why am I using PSI? Because I was too lazy to change that. So in fact, if I go here, preferences, I'm going to go to stress. Let me maximize this. I'm going to go to stress and change that to Pascal. Where is this pressure? Stress. Let's see, stress is somewhere here, right there. We're going to change it to Pascal, right there, and close it. So now, if you look at the properties here, you see that this is in Pascal, written in Pascal. Okay, good. Now I'm going to right-click, apply. I'm done with this window, so I can either minimize it or close it, and then I go to the part. You put it on the part, and basically apply it. So check mark, and there we are. Your material is right here, and if I double click this, the numbers are going to pop up. Now in the book, when I do these chapters, sometimes I do this thing differently. I create an empty shell here, and over here, when I double click on it, I fill it in. Okay, so slightly different way. Now, the other thing I want to do is I want to hide these 4 points, and there is a reason. Actually, point 1, 2, and point 3. 1, 2, and 3, I'm going to hide them. And there is a reason, because I will apply a force and some restraints at these points, and therefore some software, if you apply it to a point which is sitting on top of this vertex, it won't see it. Now I didn't try it with this program, so I'll just hit it so that there is no issue. With number 4 we have no problem. With number 5 we're down here. This has number 5 because I already inadvertently created number 4 and I deleted it. Okay, so that's fine. This one we don't have to worry about it. Okay, so we're done as far as this is concerned. Now we're going to go to structure model creation. It's we use all the defaults. Okay. So let me go ahead and mesh this thing. To mesh it, notice that there is this hidden toolbar here. So there is a mesh there, right there. Okay. Notice that as soon as I went to structural model creation, it created the finite element model, but the elements are not generated. The elements and properties are not generated here yet. Okay. So first of all, let's go ahead and mesh this thing. So this is a beam element. Now, in the previous chapter, I put one element representing this entire bar. Now here, because I want to show bending, I'm going to make sure that the mesh size is 100. That means it's going to try to put, it will put 10 elements through that length, okay? And this is very important because I want the node from the top bar and the horizontal bar and vertical bar to be identical. That means if there are any nodes within zero point 0.1 millimeter of each other, you may have to adjust this thing. For here it's okay, but in some problems you have to adjust it, okay? Then merge them, okay? So that's fine. So did I select? Let's start with this one. Select this and mesh it. Notice that it put 10 elements to this. And then we say okay. We can actually do it simultaneously here, but I rather not, because the members here, the elements here, will have a different cross section than this slanted one. So I better not uh, do them all in the same dialog box. So say okay, and then again, where's this? Then again, this one, everything is the same as before. Mesh. So put 10 element here. These two I could have done at the same time, okay? And finally, that one, why don't we use that same meshing size, mesh, 10 of, well, this is more than 10 because the length of this thing is more than 10 actually. We say okay. So notice that the elements have been created. Now we're going to have to do the properties. Now, in order to do properties, first you have to say what kind of a cross section you have and how do you orient it in space. Now, to do that, you can't do it in meshing. You have to expand this thing and go to model. See that? Model. You expand this, you go to model, and here are the different type of different type of cross sections that you have. For example, you look at this last one. This is for beams and bars and things like that. First of all, the beam profile. In other words, give me the shape of that. So we have two profiles. Profile one, it's a would it be a box, right? No, not a box. Cancel. Not a box. So I want a rectangle. Where is the rectangle? Rectangle right there. Okay. So it's going to be 24 by 24. 24 by 24. Okay, so this is profile number one. You can see that it's created here. Then another one. This is also a rectangle, but this one is 34 by 34. Okay, good. Now, the other thing that I want to do, okay, now that we have created the profiles, we can go and create the sections, okay? Beam sections. It's going to ask, what is the support? So let's do these two first, these two, okay? So this guy, can I do it at the same time? And that guy, too, these two have a profile, number one, and the orientation point is this point number 4 that I created here, and say, okay. All right. And for right, that's this one. And for the second one, beam section, this guy has profile number 2, and the orientation point is this one. The choice of the orientation point is, I don't want to say it's tricky, but you have to, if for example, this is not the way I've drawn it, then you have to make sure that you understand what the orientation point does. So that's okay. I don't know why I didn't get the first one though. Let's check this. Something is wrong here. Beam profile. I have a feeling that it doesn't like two of these. So let's try to get rid of this. Yeah, I guess you have to do this thing one for every line. So that's okay. And do another one. Uh, yeah. So for that one and profile number 1, for some reason this doesn't like it. So let me delete this. Beam section. Okay, these two are okay. Let me look at the first one. It was just that one line. Okay, let's try it again. section. This is the line that I haven't done it, and the profile number 1 and the orientation point is this. I don't know, I probably went over too quickly. So you can see that, first of all, I mean, relative to each other, this makes sense, 24 by 24, 34 by 34, and I was thinking that you could actually do these two at the same time, but it simply did not work. Okay, good. Now, let's save everything. Save everything, and I am going to uh, uh, hide the lines and these cross sections. So we go to visualization management. First of all, don't show me the model. Don't show me the model. Okay. Notice that the lines were taken away. Don't show me the elements. There we are. Of course, there's not much you can do here. So show me the elements actually. Show. Now, if I want to hide these square cross sections, you have to literally go and do this, right click, hide, and you see only the elements. But that's okay. I need actually the lines because I'm going to apply my things on the line. Okay, so let me bring back the lines. I don't need the elements and nodes, but I do need the lines. Okay, very good. All right. That's pretty much it as far as the model is concerned. Now we're going to go to scenario. So where is scenario? Right here, structural scenario creation. You're doing a structural problem. Okay. Notice that you have two red exclamation marks here because I haven't selected my elements yet. So you click on setup, you look for this guy, finite element model. There's only one that was created here, because it could be that you may want to create several finite element models. See chapter 4, the tutorial in chapter 4 that explains it, why you may want to do something like that. You say okay. Notice that this red exclamation marks turned into a green check mark. Now we go into procedure. It's a static problem that we're doing. It's a linear problem, and really here is the advanced option. Non-linearity is included, not included. I'm going to take it off because I don't want them to be included. Okay. Now we have the restraints. Okay. So this is a clamp. This bottom point is clamped. Okay. Now clamp for a beam element. These are beam element means that the translations and rotations are prevented. Okay. All right. Now this, for the top point over here, we have to say what is prevented, what is not. So we click on it. So this top point, let's see now. It cannot move. It can move in the direction, global direction Y, but not in X and Z. It's not coming out of plane, or it's not going up because of the support. Now, as far as rotation goes, we can, if we don't know, we can leave it alone like that. You know, so I'll just leave it alone like this. Now, in the book, I'm trying to see how what constraint did I put on the in the book. Let me see for a second. I'm checking. Okay, so for that top point in the book, I just bear with me for a second. I clamp the bottom. That's fine. And on the top, yeah, that's exactly how I did in the book. So we say okay. Now for the one over here, so again, fixed displacement, You select that point. Now, in chapter 7, I did the rotation here and used this coordinate system, but I don't have to do that here because I created the coordinate system which whose z-axis is along that slanted bar. So I'm not going to say global, I'm going to say specify, and specify is the one that I created. Well, I was going to pick this and it doesn't matter, so it won't take it, so I say local, and I'm going to select the one that I created. Okay, so notice that what I did, I changed the access system to local, and I picked that thing, and it basically lined this original one that I put up there with the local coordinate system. Now, in that coordinate system, it can translate along the z direction. This is fixed, but it cannot go in the direction x, nothing out of plane, and in the direction y, nothing into that support. Okay, and I leave the rotations free, and we say okay. Now, as far as the force goes, so load on this point, okay, force, where's the force? Right there. In the global direction, so the global direction, in the direction y is 1 million Newton. 1, 2, 3, 4, 5, 6. And we say okay, and there is the force. All right, so save everything. We then go to simulate. Now, I advise you to go through all 3 steps because the first one checks the model. If there are any issues, it'll let you know. No issues there. Then this one checks the simulation. Make sure that you didn't forget, stuff like loads and restraints. It's a very simple problem. It's highly unlikely you forgot anything. There may be some warning messages here, but it's a good idea to read those warning messages. I don't think we're going to get anything, but it's a good idea to do that. And then finally, if everything goes well here, we're going to run it. This last one. Okay, no problem there. And this last one. All right, it's coming along. It's a quick problem. And now if you get some messages, so if it's doing iterations and it's not in our problem because it's a linear problem, not licensing messages, plots. In this case, it's a linear problem. It's going to straight up. There's no iteration involved. Basically, one step. Or yeah. Okay. So very good. Close that. I put this thing in the front view because this is a two-dimensional problem. There's the front view. Okay. So obviously, this is the. Let's move this thing here. Select this and move it there. Okay. So let's look at the displacement first. So displacement. This is step 1, of course. No load has been applied in the 0 frame, but this is going to be moving along that. In fact, we can animate this to see what happens. You see that? It's moving along the 45-degree ramp, and because these are welded, this is what happened. So let me stop this. And 11.7 millimeter, and then you can say, okay, show me the original, the displacement. Let me see now. This is the displacement, von Mises stress. I don't want to animate these things. Let me get out of the animation mode here. Okay, so there we are. Now you have to be careful here because von Mises stress is for the cross section at every point is different. Every point of the cross section is different. You may want to look at the documentation of the way it's done in CATIA to see at what location is it giving you the von Mises stress. Notice that this is a constant. My guess is that it's going to be along the uh, that's hard to know. You really have to look at the documentation or do some debug, do some detective work to find out where it is. It can't be the it can't be the, it may be actually the centroidal axis. Okay, so yeah, please check the documentation. And then now, if you want to get, for example, just hypothetically, you want to get the deformation, undeformed configuration here. See, this is single plot. Every time you plot something, it deactivates the other one. So if you click on it, then anything that you plot is going to be on superposed on this. For example, if you look at the undeformed model, there you are. The undeformed model looks like that, and the contour of stress looks like this, okay? And if you want to look at displacement, obviously it's going to be on top of this. Now, if you don't want to see these, get rid of these. So one way to do that is find out what stuff you have plotted and deactivate it. So uh, these are my plot. So for example, if I don't want one message, you put the cursor there, right click, deactivate, and it gives you the displacement and the undeformed. Yeah, so that's pretty much it. This is the how to do it, tutorial wise or video wise, and with the book, you're in good shape for these type of problems. Good luck.